All right, so this is just a quick little video to remind us a little bit about rational function and behavior. So your homework assignment for next week. So it's not due until next week when I see you. So either Tuesday, Wednesday, Thursday, or Friday, just depending on which day I see you. Is this worksheet about how we find the end behavior of a rational function. And we talked about this back in the last chapter, but this is just a video to remind you. So if you're having trouble with it, then you watch this and it'll kind of hopefully help you figure some of that out. So if you look at the instructions at the top, right, it says that to do it using this called the comparison method. And so what that means is, right, we're just going to compare the degree of the top to the degree of the bottom. So remember that our new definition here of a rational function is that it's a polynomial divided by a polynomial, right? So when I look here at this new function g of x, right, this top function is a polynomial and the bottom function is also a polynomial. So as a whole, this would be considered a rational function. So normally to figure out end behavior of a polynomial, right, we know that we would look at the highest degree. And so up here in the numerator, the highest degree is negative 3x to the fifth. And then down in the bottom, the highest degree is negative 6x to the fifth. So when we talk about a rational function, instead of just looking at each one of them individually, we want to look at that as a whole. And so essentially, when we talk about the comparison method, what we're going to do is just look at that negative 3x to the fifth over negative 6x to the fifth and think about how that would simplify. All right, so in this case, because they're the same degree in the top and the bottom, those x to the fifths would entirely cancel out, and negative 3 over negative 6 would actually just equal 1/2. So in this case then, the limit, so our end behavior, so just to practice that limit notation again, so the limit of the function as we go to the left, so as I go to negative infinity, is going to be 1/2. Right? And then the limit of the function as I go to positive infinity is also going to be 1/2. So remember that when we look at those degrees, if they turn out to be the same on the top and the bottom, then we just simplify that to figure out what number this function is essentially going to level off at, right? So in both directions, then this graph is just going to level off at a y value of 1/2. Remember, we're allowed to do this because it's end behavior, and so the highest degree pieces take total control of the top and the bottom, right? When I'm raising a big number to the fifth power, like if I raise 100 to the fifth, that's 100 times itself 5 times, right? That is way bigger than these other two numbers, and so I can essentially ignore them, right? So that's the reason that this is legal mathematically, if you will. So let's take a look at another one here. So in this next situation, we've got the function b of x. So if I do the limit of b of x as I go to the left, so we're going to try to figure out what that does. And the limit of b of x as I go to the right. So again, we're going to just use this comparison method, is what we'll call it. And so essentially all that is saying is, again, look at the numerator. So that's a polynomial up there, and that right there, negative 320x to the sixth is the highest degree. And then down here in the bottom, the highest degree is the 15x to the eighth. So when I come over here and take a look at those, I'd have negative 320x to the sixth over 15x to the eighth. Now the numbers would simplify, but I really don't care about that because I just want to take a look here at what happens with the x's. So notice that in this case, when it simplifies, right, the x to the sixth would cancel with the x to the eighth and just leave me with an x squared down there. And so whenever the degree is bigger in the bottom, we end up with an x left down there. And so whenever there's an x left in the bottom, if you think about, right, if I'm plugging in some number, some really big number, like, even 100, right? then that means that this number on the bottom is going to be 100 squared times 15. So that, excuse me, that denominator is going to be so much bigger than the numerator. And so whenever the degree of the bottom is bigger, then the limit to both the left and the right just turns out to be 0 because I'm dividing by such a large number, okay? So using that comparison method again, so up here in the top one, if they were equal, then it's simplified down to whatever number it simplifies down to. If the degree of the bottom is bigger, then it's going to be 0. And so then the third case is if the degree of the top is bigger. So if I look at this situation, so if we do the limit of c of x as I go to the left, and I do the limit of c of x as I go to the right. So again, I just want to look at the highest degree pieces. So that would be negative 8x to the 6th up top, and on the bottom, that would be the 4x cubed, right? So if we take a look at just those pieces, then we'd have negative 8x to the 6th over 4x cubed. So that's going to be negative 2x cubed. So in this case, it simplifies, right? So the x to the 6th over x to the 3rd, because the x power was bigger in the numerator, then it actually simplifies down to a polynomial. So what that means is that this time the end behavior is going to do what this polynomial would do. So since this is an odd degree poly with a negative leading coefficient, we know that if it's odd degree, they're going to go in opposite directions, and the negative leading coefficient is going to make it go up, down. So in that case, then, as I go to negative infinity, it went to positive infinity, and as I went to infinity on x, then it goes down to negative infinity, okay? So these are essentially the three cases. Right? So it's always going to be one of these three things. So just to summarize, right, case 1 is if the degree of the top equals the degree of the bottom. Okay, then whatever it is like, so if I have ax to the n over bx to the n, that's always going to simplify then to just a over b, right? So if the degree is the same, so it's always going to simplify to just whatever those coefficients are, and that's where it's going to level off, right? So it levels off at that value. Okay? So that's case 1. Case 2 is if the degree of the top is less than the degree of the bottom, or in other words, the degree of the bottom is bigger. And so whenever the degree of the bottom is bigger, it always levels off at 0. So this is the easiest one, because as soon as you notice that the bottom has a bigger degree, it always levels off at 0. And then case 3 is kind of the hardest one. That's the one where the degree of the top is greater than the degree of the bottom. And in that case, right, it's going to simplify to a polynomial, and it follows that in behavior. So that last case then, when the top is bigger, after you simplify, whatever the polynomial is that you get, you got to look at the degree, you've got to look at the leading coefficient, and it's going to do whatever that type of polynomial does, right? So it's either going to go up, up, down, 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 up, or up, down. Okay, so those are the three cases. It's going to fall into one of those three. So give those a try on that worksheet, kind of using this method, and write all your answers using limit notation just to practice that. And I will check that off for you. It'll be your first assignment that's due in the second quarter. So for some of you, that'll be Tuesday, some of you Wednesday, others Thursday, and others on Friday. So that's it. I hope that helped. Have a great weekend coming up. Nice long weekend.